Hello guys, so now we'll start with the next branch of mathematics, which is the integral calculus. Now this is the second branch of calculus. The first one is differential calculus. The calculus is divided into two branches. The first one is differential and the second one is integral. Now if we use the right approach, you will understand this both differential as well as integral calculus very easily. But if the approach is different, then they are very hard to understand. So we will start with the integral calculus as the anti-derivatives. Okay, just understand this term first, anti-derivatives. So we have learned how to calculate the derivatives. Now we'll see how to calculate antiderivative of a function, of a given function. So let's see what I mean by the antiderivative. Now guys, first of all, write down the definition, then I'll explain you with examples. A function capital F is an antiderivative of function small f on an interval I if f dash x, now this f is capital, is equal to fx for all x in the interval I. So let's see the definition first. Let's first try to understand this one. A function f is an antiderivative of small f on the interval I if capital F dash x is equal to small fx. Now a function will be known as the antiderivative of a given function if we obtain the given function by the differentiation of that function. So if I do the differentiation of this function and I get this function, then this function is known as the antiderivative. This is very easy concept. In this case, fx will be the derivative which we studied in the differential calculus. Fx is the derivative of capital Fx, while on the contrary, capital Fx will be the antiderivative. Capital Fx will be the antiderivative of small fx. So just understand this term antiderivative first, that if I do the differentiation of this function which is the antiderivative of fx, I will get the same function fx only. So let's understand the concept of antiderivatives with example. So the first example is fx is equal to 2x. So the first example is fx is equal to 2x. So can you tell me guys, what is the antiderivative of fx is equal to 2x? Now see, now antiderivative, just remember the definition, that if I do the differentiation of that antiderivative function, I will get that 2x. So I have to find such a function capital Fx whose differentiation will give me 2x. Now we know that in case of algebraic function, this function will be equal to x square, because the differentiation of x square gives us 2x. Therefore fx is equal to x square is the antiderivative of fx is equal to 2x. So this is antiderivative of small fx. So this is the first one. Let's see the second one. Fx is equal to, let's say, cos x. Now find the antiderivative of cos x. So the antiderivative means that such a function whose differentiation gives us cos x. Now we know that such a function is fx is equal to sin x. Therefore sin x is the antiderivative of cos x. Similarly, fx is equal to, let's say, the third one is sec square x or secant square x. We know that in case of trigonometry, now whose differentiation is equal to secant square x? What is that function? Now that function is capital Fx is equal to tan x. Therefore these are the antiderivatives of the three given functions. Now let's jump to conclusions in this case. So first, we'll see algebraic functions. Now guys, see this very carefully. If a function has a derivative 2x, we can say that the antiderivative will be x square. So this will be the derivative and this will be antiderivative. Similarly, if we have x cube, derivative is equal to 3x square, while the antiderivative will be equal to x cube. So that's the difference between the derivative as well as the antiderivative, right? So we can judge from here that in case of algebraic functions or in case of power functions, we can see that in case of differentiation, the power is decreasing or the exponent is decreasing. Here the exponent was 2, here the exponent is 1. But in case of antiderivative, the power is increasing, right? So that's the beauty of integration and differentiation. In the case of differentiation, the power is decreasing, while in the case of antiderivatives or the integration, I will tell you how this is called an integration, we are getting a jump or a change or an increase in the power. So here you can see that the power is increasing. So we can generalize the formula for algebraic functions also. So let's make a chart. So this is my function fx, and here we'll write the antiderivatives. So the first function is x to the power n. Now guys, I told you in the case of derivative of this function, the power will be reduced, but in the case of antiderivative, this power will be increased by 1. Now guys, there will be a factor which will be multiplied by this algebraic function. Now can you tell me what will be that factor? Now the meaning of antiderivative is that if we differentiate this, I will get x to the power n. So now you try to differentiate x to the power n plus 1, you will get n plus 1 times x to the power n, right? So I will get n plus 1 times x to the power n. Now you can see that you want x to the power n, therefore you have to divide this by n plus 1. So therefore the antiderivative of x to the power n will be x to the power n plus 1 divided by n plus 1. If you're not able to understand, I'll repeat once again that in case of antiderivative, I know that power will increase by 1 or the exponent will increase by 1, so it will be x to the power n plus 1. Now we know that the differentiation of this antiderivative will give me the original function. Now you see the differentiation of x to the power n plus 1 will be n plus 1 times x to the power n. But I want x to the power n, therefore if I divide this by n plus 1, I will get the differentiation n plus 1 x to the power n plus 1 divided by n plus 1, which is x to the power n only. So therefore we can say that the antiderivative of x to the power n is equal to x to the power n plus 1 divided by n plus 1. Now let's see one other one, which is cos x. Now guys, in the case of cos x, we know that cos x is obtained by the differentiation of sin x. So therefore the antiderivative of cos x will be equal to sin x. It's that simple. And next see sin x. We know that sin x is obtained by the differentiation of cos x, but with a negative sign, right? If we see the differentiation of cos x, we'll get minus sin x. So if we want plus sin x, I will differentiate minus cos x. So therefore the antiderivative of sin x will be minus cos x. Similarly, the antiderivative of secant square x will be equal to tan x. The antiderivative of the next one, which is cosecant square x, will be equal to minus of cot x. The next one, the antiderivative of secant x tan x is equal to secant x. And similarly, the last one, which is cosecant x cot x, its antiderivative will be equal to minus of cosecant x. Now you just have to remember the concepts of differentiation or derivatives. You will understand the concept of antiderivative very easily. Now this last one, if it is not visible, I'll write again. So this one was secant x and the last one is cosecant x, cot x, and the differentiation is minus of cosecant x. Right? So that's the whole chart of antiderivatives of the algebraic or the power function as well as all the trigonometric functions. Now these are the antiderivatives or the trigonometric functions which we learned in the